Hello and good evening, everyone. Thank you for joining me today in this session. So today in this session, we are going to begin this project on singly linked list, or let me say linked list. So what is a linked list? A linked list is also a way of representing data, just like an array. Okay, we know what array does, right? We know how to use arrays. Arrays are used to store data of the same data type, isn't it? So same applies to linked list. Okay, but we know that arrays store these data in sequential order, isn't it? It is sequential representation of data. But in the case of linked list, it is not sequential. It can be stored anyhow. Let me give you an example. So here, let me take this off. All right. Okay, so assuming I have this now, 20, 25, and let's say 30, right? Let's say this is stored in an array. We know this is how it is going to be represented in the memory, right? Something like this, isn't it? With the address, let's say this is 10. So since this is an integer, the next one will be what? 14, because we know size of int is 4 bytes, right? Then this one will be what? Will be 18. So that's why I said it's a sequential representation of data. But in the case of linked list, it is different. Assuming I have this 10, 20, and 30, I want to store them using, I want to represent them using linked list. So the first thing I need to do is this. We first need to know that the linked list is a list which is made up of nodes that consists of two parts. A linked list is made up of nodes which consists of two parts. This is the node. The first part here is what is the actual data that you want to store, and this is the link part. And this link part is going to link to the next node. You'll see what I'm trying to say. So assuming I want to represent this 10, 20, and 30 in a singly linked list, all I need to do here is I will do something like this. This is the data part, right? So it will hold 10, isn't it? And then this part here, this second one, the data type is what is 20, and this third one here, the data type is what is 30. So assuming the address of this node is, let's say 20, or let me use 10. For instance, the address is 10, isn't it? And the address of this is, let's say 20. So what will happen is this node here you are seeing, the link part is supposed to hold the address of the next node. So and what is the address of this node? We assume it is 10. So this is going to be 10. Or let me make it 100. This is going to be 100. So this is now pointing to this node directly. Let me just delete this, the whole of it, and let me do something again. Let's say I have 20, 25, and 30. I want to represent this using a linked list, right? Assuming this is it, we said it contains two parts, right? The data part, isn't it? And also the link part. The data part contains what? The actual data that you want to store, while the link part is what? Pointing to the next node. So in this case, assuming I said this is holding, let's say 100, let's say this is 200, and this is 300. This is just an assumption. So this link part here, the link part of this node is going to point to this node here, the second node. And what is the address of the second node? It is 200, right? So the link part here is going to hold 200. So this node now is pointing to this node, right? So and this node, the link part of this node should point toward to the next node, which is having an address of what? Of 300, isn't it? So now we have created what? A linked list. A linked list. From the name you can be able to understand what this does. A linked list. So it contains what? It is made up of what? A node, and it is the node consists of two parts, which is the data and the link part. But one thing we need to understand is that the linked list is not just a singly linked list. We have other types of linked list. Okay, we have the singly linked list and also the doubly linked list, or they used to say double linked list. So the singly linked list simply means linking in one direction. It just goes in just this direction. Okay, you can only move forward in forward direction. You cannot move backward. So what this is saying is that you can only start your link from this, check whatever is in this second node, and check whatever is in the other node that comes after. But you cannot start from the last node and be going backward. Okay, so that is why this is called a singly linked list. Okay, so this is just what a linked list is. So but before we proceed solving examples, we need to understand something. Now we've created this list. how can we access this first node here? Because we know that for us to have access to the second node and the third node here, sorry, one thing I forgot to explain is, since this is the last node here, the link path is going to hold what? A null. So always the last node has to have what? Null as the link, because it is not linking to any other node again. I believe this is clear. So what I was saying is, how can I even access these nodes here? I cannot access this node without having access to the first node. I cannot access the third node without having access to the second node. And this first node, now that I need to have access to it before I access the others, how can I access it? So this way, we are going to need a pointer. So let me call it something like this. Let's call it head. It is normally called the head actually, because it is the first, or should I say, it is the pointer that is pointing to the first node. So in this case, what is the address of the first node? It is 100, right? So this is going to hold 100. Do you get it? So this is now pointing to this directly. So you first need to node your head, right, before you be able to node the first node and then second node and then the third node and whatsoever. So now we've created what? A linked list. Do you get it? Don't forget, this is a pointer. Okay, this is a pointer. So you definitely need a pointer if you want to create a linked list. Do you get it? Also, for us to create a linked list, we need what is called a self-referential structure. Do you get it? We need to know what a self-referential structure is. A self-referential structure is simply a type of structure which contains a pointer to the structure itself. Do you get it? Just like how we do in case of functions, recursion, right? When we're talking about functions, we know recursive functions that call themselves, right? But in this case, self-referential structure is just a structure that is calling itself. Example, let's say I have something like struct ABC, right? Let's say I have something like this, right? And it has, let's say the members, we have int A and also int B, right? So I want to create a self-referential structure for this. So what is the structure name? It is called struct ABC, right? So I can simply just say struct ABC and then what? A pointer. Why am I using a pointer? Because I want to be able to create a node for this, right? So let's call this link, for instance. Then I will close it here. Do you get it? So this is just an example of self-referential structure. Or in our own case, since we are dealing with just one data, I can decide to clean this, just this part here. Let me just do something like this. So I can just say int, sorry, not int. It's supposed to be what? Struct, right? Struct ABC and then what? And then link. So this is what a self-referential structure. Okay, so this means that I can be able to create this node here by calling this structure again. So this means that this structure is going to contain what? An element of type int, isn't it? Which is 25, considering this second node now. Okay, which is 25. And then the struct ABC asterisk link, this is a pointer. And this pointer here, this link pointer, is pointing to another node that is supposed to contain an integer and also a link path. Do you get it? So int A is the data part. So this part here is a pointer. This is saying that this is a pointer. And this pointer is pointing to another node that should have A and also a link path again. So that is why I said it is most to have a self-referential structure for you to be able to create a linked list, or for you to be able to create a node in what? In a linked list. Okay, so I think this is all we need about the introductory part. I think now we can begin solving tasks. So just know that you need a self-referential structure to create a node, and just know that a node contains two parts, the data part and also the link part. The data part is where you put the actual data, and the link part is a pointer that is pointing to the next node, which contains a data and also a link. So we need to know that also for us to have access to the first node, we need to create a pointer which will hold the address of the first node, just like what I did here. Okay, I believe this is clear, right? All right, so let's begin solving examples. Okay, so all right, so before we do anything, this is the data structure they gave us that we're going to use. So when you look at this, actually it is being printed in the next line. Let me just do something like this. Okay, so when you look at this here, this is what? A structure, right? And it is a self-referential structure. When you look at this, this is struct list underscore s, right? This is the struct list underscore s. So this is what calling, or it is pointing to the structure again. So this is what a self-referential structure, right? And this structure has three members. The first member is what is pointer to a string, and the second one is an unsigned int len. And I guess this part here is going to hold a string, and then this part here is going to count a length, right? And this is going to point to the next node. Okay, I've already explained what a self-referential structure is, right? So firstly, you need to copy this and make it available in your main.h. Sorry, not main.h. In this case, we are creating list.h. So just read the instruction from the intranet. So it is list.h. So as you can see, this is what the main.h file. As you can see, I have this structure inside. This is it. I have the structure, and also I have the prototype to all the functions I'm going to solve for this particular project. I have my putka function. This is the prototype for the putka function, and I have created the putka as well. Okay, so just vi underscore putka.c. So as you can see, I have my putka, right? So everything is set now. This is not something that I need to explain again. I'm sure by this time you are all familiar with how to use all these things. So let's begin solving the examples. So this task here says we should write a function that prints the element of a list underscore t. Don't forget, this is what a structure. We've created this as a structure, right? This is the structure they gave us, list underscore t. Did you see it here? List underscore t. So we are asked to what? To print all the element of the structure. Do you get it? So this is the prototype. It says return the number of nodes. So we are also going to return the number of nodes, and also it says the format we should see example. If str is null, print 0 in square bracket and then nil, you are allowed to use printf. Okay, so what this means actually is that we are going to print all element of a list, right? And this is how we are going to print it. When you look at this, we got what? 5 first printed, and then what? Then a string. So this 5 here is the length of the string. When you count, we have HELLO, 5, right? And then here we have another 5, which is for what? For world, right? And in total, how many nodes do we have here? We have 2 nodes, the one for hello and one for world. So that's why we're having 2 elements here. Same applies to this. Okay, so here it is 0, and that's why we got what? A nil printed, because we are going to set a condition for nil as well. So here we have world, it is 5, that's why we are getting 5 as the length of the string. And in total, we are having 2 nodes as well, which is for this part. Okay, so that's just what we are going to do here. Do you understand? So here, this is where the list underscore t data type is passed, and it is used on a variable called hello, right? So it means this hello is going to contain 3 members, because our list underscore t contains what? 3 members, right? It contains, the first one is what? The first one is a string, right? A pointer to a character. So that's why we are having world here. This is a string. And the second one is len, if you remember, int len, when we are creating that structure above. So int len, and this is what? 5. It means this is the length of the string. And the third one is what? Is a pointer to another node. So since this is null, it means it is not pointing to another node. I believe you understand this. So that's just what this means. So we are going to create a function that does exactly something like that. Okay, so let me open the file. I called mine 0 print. Okay, so as you can see, I already have Betty documented. Please take note of the name here. So in your own case, use the correct file name, please, from the intranet. Okay, so I already have my Betty documented here. So when you look at this, it contains what? Const list underscore th. So I told you that for you to create a node, you need what? You need to create a pointer, which is called the head, or which we normally call the head. And this pointer here, just look at this. This pointer here, that is it. This is it. The head, it is going to point to the first node, and then from the first node, you can get access to all the nodes, right? So you need the head. So this here is just going to take the address of the head. Do you get it? So what I need to do here is I'm going to return the number of nodes, right? So when you look at this, the function is returning size underscore t. So I will just call size underscore t. We all know why we use size underscore t. It can be an unsigned integer, right? I don't need to explain this. So let me call mine, it says number of nodes, so let me call it, it says number of nodes, right? So let me just call it nodes here, right? So here, what I need to do here, or let me not use nodes, actually, let me just look at it here. Okay, in their own case, as you can see, they're using elements, right? It's just a text. So let me just give mine something like element as well. Or let me just leave it like this as nodes. It will not make any difference, okay? So I need to initialize nodes to be equals to 0 since I'm going to count it. So initialize from 0. So you start counting from 0, 1, and whatever. So the next thing I need to do here is I need to check what if this h here is equals to null. If the pointer here is null, that means if the head part here, if this part here now, if you are having null here, so what does this mean? It means we don't have any node, isn't it? If it is null, we don't have any node. So I need to check if it is not equals to null. So only when my h here, my pointer h is not null, that is when I need to do something, right? So I can simply create a while loop and say while h is not equals to null. So this is when I want to do something. Only when my h is not equals to null. Right? Because if it is not equals to null, that is when I know that, okay, we have a node. Because if it is null, then there is no node. Right? So if it is null, if it is not equals to null, there is a condition here given to us. If str is null, print 0 and then nil. So I need to check if what should be the condition. Don't forget, I need to access this part here now. I'm checking for this part here, this node. Right? So, and this is the head. Right? So how can I access the data part of this node? I can simply use head and then the arrow notation and then what? Data. This will point to what? The data of this particular node. Do you get it? It will point to the data of this particular node. Assuming I want to point to the data part of this second node here. So all I need to do here is change this. Right? I need to add link. Do you get it? So it means that it is going to point to what? This link part here, right? So what is the link part? It is 200, and this 200 is pointing to what? This node, right? So and I will say what? And I will say data. So what this is going to do is simply, it will navigate the head. In the head, we know that it is pointing to this part. So what is the link part of this here? The link part is what? Is 200, isn't it? And 200 is the address of which node? Pointing to this node now. So what is the data part of the node? It is 25, right? So I can simply access each node using this notation here, using the arrow notation, isn't it? So here I need to check if whatever, or the str part, right? Since we are printing string, right? If the str part of this node is equals to null, that means this part here, assuming this is containing what? A string. So assuming this part here is null. Right? If it is equals to null, we are told to print what? Null and then what? 0 with what? A nil here. So I'll just say h str. Why are we using str? Because from the structure here, just look at the structure, it is str. So I'm just saying that if the str part or the string part of this node is equals to null, right? If the string part, let me move this, is equals to null, then I need to pass in this condition here, right? So what should be the condition? So here I will say printf. So as you can see, we are printing 0 and what? And nil, right? So this 0 is a what? Is an integer. So I'll use %d. And then the nil is what? A string. So I'll use %s. So on a new line, /n. So here I'll simply just pass in 0 to replace the placeholder d. And also here I will pass in nil now. Do you get it? So if hstr, that means if the str part, where is it? If the str part, that is the data part in this case, which I called data, if the str part is null, that is if there is nothing there, right? If there is nothing there, then we should just print what? The length is what? Is 0. So we have 0 and also nil here, right? So else, that is if there is something. Right? If there is something, what should we do? Here, let's just look at the output. We are going to print what? The length and also the string. Isn't it? That's what we're going to do. So I'll just say printf here. I'm printing the length, right? So I'll just say %d here. And then the string, right? So %s. And then a new line. So here I will pass in what? This place is supposed to contain the length. Isn't it? And the length is stored in which member of the structure? We have the length. Isn't it? So the length is holding the length of what? Of the string. So here I will just say h and then len. So take note, for me to access the data of any node, I need to first call the head because it is the pointer to the first node. Okay, so for you to access any data or any link in a node, you first need to access the head. And the head is this part. I've already explained this part. You need it to have access to the first node. Okay, so I'm printing what? The length part here, sorry, the length, and then what again? The string. So this is going to be what? H what? str. Isn't it? So here I'm printing the length, and also this is going to print the string. Right? So the next thing I need to do is what? After this, I need to move to the what? To the next node. Isn't it? H here is pointing to what? To this first node. Right? So I need to update the value of H now to point to this next node here, because I'm printing everything of the node. So I need to point to this next node. Right? So it means now I need to update my head to hold the address of this node here. Right? Assuming the address of this node, like I said, is 200. So I need to update the value of head now to hold the address of the second node. In this case, my head will now hold 200. Isn't it? So head is now pointing to this node directly. So I need to now update the value of what? Of H. So don't forget, the value I need to update to H is the link part of what? Of the first node, which is 200. Right? So here, all I'm going to do here is I'll just say H. I'm updating the value. H is now equals to H asterisk. So let's check what is holding. Okay, as you can see, the link part now is called next. Instead of link, it is called next. So here I will just say next. So this next here is pointing to the next node. Do you get it? Next here is pointing to the next node. So now I've updated the value of H to hold the link of the next node. So with this, I'm going to access the second node here. When I'm done with this, I'm going to access the third node here. Okay, I just updated the value of H. Initially, H is pointing to the first node, right? So once I'm done with the first node, I need to update the value of H so that it will point to the next node. And this next node we want to access is what? Is the link part of what? Of our first node. Our first node already has the value of the next node that we want to access, isn't it? So that is why I said, okay, now my H, we know my H is initially pointing to this. So the link part of H, which is this 200, so it will point to this part here. So I just updated the value. Okay, so after this, what next? Then I need to say node plus plus, right? So after printing each node, you should what? Increment the value of nodes. This way I'll be able to get the exact number of nodes, isn't it? So the next thing here is I will just say return, I will now return the length or the number of nodes, which is called nodes. Okay, so this is simply what? How we can do this. So let's save this and exit. Let's run Betty first. 0 print. All right, Betty is fine. So let's create the test file 0 main.c, right? All right, so let me copy it. Copy the test file. Oops. All right, so copy and then let's paste here. All right, so let's compile this and let's see if we are going to get the same output. Copy and then oops, copy again. I need to copy again. Okay, copy and then paste. All right, what? Okay, my file name is not printlist.c. I just called it print, right? So enter. Yeah, so it has been compiled. So let's run the compiled file. So as you can see, we got the exact output. We got the length of the character printed, and then what? The string, and then the number of nodes, isn't it? And then the number of nodes. Same applies to this. So don't forget, add, commit, and push to a GitHub, and then you can run your checks. So now let's move on to the next task. So this task here says we should write a function that returns the number of elements in a linked list. So when they say number of elements, it's just like how many nodes you have. Okay, so the number of elements in a linked list. Okay, so let's open the file. This is the prototype. So vi, I called mine, I think, is it one print? Yeah, one print.c. So as you can see, I have my Betty documented already. So as you can see, this is also containing what, or taking what? The header, right? The pointer to the head, because like I said, we need to have access to the head first before we can access any node. Do you get it? So we are trying to find the number of nodes, right? So let me create another variable. Let me call it nodes again. I'm going to call it nodes, and I'm going to initialize it to 0. This is going to hold the number of nodes. Why am I using size underscore t? Because I'm returning the number of element in a linked list. And when you look at this, it has what size underscore t as what its return type, isn't it? So that's why I did that as well. So firstly, we need to check if our head is not equals to null, right? That's the first thing we normally need to do. We need to check if the head is not equals to null, because it is when the head is not null that we know that we have other nodes to check, right? So I will now say while h, that is the head, is not equals to null, right? So while the head is not equals to null, then what do we do? When the head is not equals to null, I want to count the nodes, right? So if it is not equals to null, then I need to update the value of h now to point to what? To point to the next node. And I will say next. Sorry, I need to say h equals to h next. Do you get it? So what I simply did here is that we know that initially h is going to point to the first node, right? So this is saying that h is not equals to null. That means h is not pointing to a null node, right? So h is now equals to h next. So I'm updating the value of h to next. So here after this, I will now say nodes plus plus. So as you can see, this will what? Change the value of h to what? To point to the next node. And I will now increment my node. So now the value of h is now pointing to what? To the next node, right? So if it will check, is it equals to null? If it is not equals to null, then it will update the value of h again and then increment the value of nodes. So as you can see with this, I'll be able to count each node. I don't know if this is clear. This is not confusing as you think it is. It is very simple. Okay, it is very simple. You just need to understand the concept. Anything you need to do, you need to have access to the head first for you to be able to get access to each node. Okay, so that's why here before I increment my node, I need to update the value of my head to point to the next node. I don't know if this is clear. Okay, so the next thing I'm going to do here is I'll just say return nodes. So this will return the total number of nodes. Okay, here I first check if h is not equals to null. That is if the header or the head, right? Something like this. Let me do it again. If I have something like this, it will first check this head. Is it equals to null? Or let me say my h, let me call it h. H, is it equals to null? If it is not equals to null, then we know that it contains a value, assuming 1000. And this value here is pointing to what? A node here, right? It's pointing to what? A node. And this node contains what? str, and also this part here is what? Next. So this is going to contain what? The address of the next node here, assuming this is now 100, right? Isn't it? So let's say this we have AB, and then we have AC, for instance. So as you can see, this head is now pointing to this node, isn't it? So we've checked that h is not equals to null, and it is not equals to null because it contains what? The address of this first node, right? So if it is not equals to null, then I want to move to the next node now. Since it is not equals to null, definitely I know that this node exists, right? Because if it is null, then that way I know that there is no node. But since it is not null, then definitely the first node here exists. So I have one node now, right? Now I have one node. So here I updated the value of h. Where is it? Here I updated the value of h to now move to the next node because h is not equals to null. I know I have this. So now I'm saying, okay, h, since I know that this node exists, now I want my head to point to this, my h to point to this. And how can I make my h point to this? I simply need to update the value of h to be equals to what? H what next, right? Because next is the point. Because next is holding the address of the next node here. So that's why I said h next. So now I have my head pointing to this. Okay, so that's how it will keep going, and I will keep incrementing the value of node, and then I will return node. Okay, so let's run Betty on this. One print. Okay, trailing white space in line 12. All right, so let me check. Okay, yeah, I see it. So let's run Betty. All right, so now let's create the test file, one main.c, right? So let's copy this. All right, so copy vi1 main.c. All right, so let's paste. All right, so now let's compile the program and let's see the output. and let's see the output. So copy this and then paste here. So here, instead of this, I called mine one print, right? One print.c. So take note, I'm using a different file name, okay? Not the same as yours. All right, so it has been compiled. So let's run the compiled file. So as you can see, we got what? 2 elements. Same as this here, we got 2 elements. Do you see that? So this is simply how you can do this. Please, you can just go through the test file here. You'll understand what I just did. Okay, I'm sure you'll understand what I did. So don't forget to add, commit, and push to your GitHub, and then you can run your checks. So now let's move on to the next task. All right, so this task here says we should write a function that adds a new node at the beginning of a list. So I'm going to add a new node at the beginning of a list. So this means that assuming there are nodes that are existing already in the list, so what you need to do is to create a node now and make sure that node is now the first node in the list, isn't it? Assuming you have something like this. Let me do this. Assuming we have this node, right? This is one node. We also have another node here and also another node, right? We know that this is the first node here, and it is being pointed to by the by the head, isn't it? Assuming this is the head, right? So it is being pointed to by the head. So what we need to do is to create another node aside. After creating this node, then we need to do some things to make sure that this node is now the first node. So it means our H is now supposed to point to this node. I'm just giving you a summary of what we're going to do. Don't worry, I'll explain it step by step. Okay, so what we need to do is just to make sure that this new node we created is now the first node. It's now the first node. Okay, that's also what we need to do. We just need to make sure that this node is not the first node in the list. So it means that our head here should be able to point to this new node, because it is the node that the head is pointing to that is the first node, right? So that's what we're going to do. So that's simply what the question is asking us to do. Okay, all right, so let me open the file. So I think I created the file. I called it to add. Yeah, so as you can see, I have my ability documented here. All right, so what's the first thing we need to do? In this case, since we are creating a node, right, it means it needs memory, right? That node needs a memory. It needs memory to store the data, and it also needs memory to store the link. So here we are going to use malloc to allocate memory to our new node. And we said if we are to use malloc, then we need a pointer to store the return value of malloc, isn't it? So here I'm going to say list underscore t. Why am I using list underscore t? Don't forget, this is the structure we created, right? So it means that whatever I want to create here is going to hold str, it is going to hold len, and it's also going to hold link, right? So I'm going to call this, let's say, new node, right? New node. So I've created a pointer called new node in which I'm going to use to store the value or the data of the new node in which I want to create. So the next thing I'm going to create is I'm going to initialize a variable which I'm going to use for my looping, because I need to find the length of this str. Okay, this str here, you're saying I need to find the length of the str because I need to attach the len to this structure, len part. Don't forget the structure here is having len, right? So I need to know the length of the str string so that I'll be able to store it here. Do you get it? So that's why I need to find the length of the string. So which task? Yeah, so that's why I need to find the length of the string. So I'll just say unsigned int. Why am I using unsigned int? Because the len in the structure is of type unsigned int, or if you like, you can use size underscore int anyhow. So I'm going to call it I. I'm going to use this for the looping, and then I will declare another variable which is which is count, in which this is going to hold the number of characters. For each iteration, count will be incremented. Okay, so now the next thing we need to do is to call malloc to allocate memory for our new node. Here we just created the pointer new node, right? So I'll just say new node now is equals to malloc, and then size of what? So what is the size of the memory we want malloc to allocate for us? It should be size of list underscore t. That is size of this structure here. So that is size of this structure here. I want the exact size of this structure to be allocated to new node, because I'm going to store car, I'm going to store len, and also the next inside this new node. So the size should be size of list underscore t. I believe this is clear, right? So the next thing I'm going to do here is say list underscore t. That's the size. Sorry, not y. List underscore t. Okay, so the next thing is I need to check if new node is allocated, if memory is allocated to new node, right? So I can now say if, don't forget this is something we've been doing when we're talking about malloc. We need to check if malloc fails or if malloc allocated the memory successfully. So I will say if new node is equals to null, it means what? The memory is not allocated, malloc fails, right? So what should happen? I'm going to return a null, right? So I'll just say return null. Return null. Isn't it? Yeah. So I'm done with this part now. If malloc fails, then it is going to return a null. So the next thing I'm going to do here is I need to now add this str, this string, whatever this string is, I need to store it in the str member of the structure, right? So what I'm going to do here is I will now say new node, right? I want to store this string now, whatever this string is, inside the new node I want to create. And inside this new node, in which member do I want to store string? In the str member, right? So it means go to the str member of new node. Don't forget, new node is of which type? Is of list underscore t. So it means it can hold str, it can hold len, and it can hold what? Next, right? So go to the str member of new node and what? And I want you to add whatever the set of string is. So in this case, I'm going to call the strdup function, which is string duplicate. So, and I'll pass in str. So what this is going to do is it will create a copy of str here and store it inside this. It will duplicate the string. Okay, so that's just what this does. So the next thing I'm going to do is to find the length of my string. So I'll say for I equals to 0, this is not something new, str index I not equals to the terminating null byte, right? Not equals to terminating null byte, then I plus plus. This is something we've been doing for so long, right? So here I will just say count plus plus. So count here now is now having the length of the string. Please don't expect me to explain this for loop, okay? So count is now having the length of the string. So the next thing I'm going to do here is, don't forget, here I've already assigned str to our new node now. So the next thing I need to assign to the new node is the len. Don't forget, the structure has what? Len, and that len holds the length of the string, right? So now I'll now say my new node, in which member of the new node? The len member of the new node, right? Is equals to what? I now need to store what? The count variable here, or let me say the number of characters we count, which is stored inside this count variable. So I'll just say count. Do you get it? So now I have new node len. It now has the value of what? Count, which is the length of the string, right? So the next thing we need to do is this. This is one of the, or it's a bit confusing, but I will try my as much as possible to explain this concept, right? So assuming I have something like this, this is a node, right? Assuming this is a node and it has A and B, right? And this is another node, it has AC here, and this part here, since this is the last node, it contains what? A null, right? And let's say this has an address of, wow, my screen. Let's say this has an address of 100, right? 100, and this one has an address of, let's say, 50, right? 50 and 100, isn't it? So this here is going to contain what? 100, right? And our head here is going to point to this, right? Our head here is going to hold what? 50, right? The address of the first node. Our head is now going to hold 50, isn't it? So now I've created my new node now, and I want this new node to be attached to the first. I want my h now to point to what? To this new node. Assuming the address of this node is, let's say, 20, right? The address of the new node is now 20, and here it has let's say zy, for instance. It's just instance I'm giving here, zy. So how can I make this new node we just created to be the first node? To make it the first node, it means this head now needs to point to it, right? Because the head always points to the first node. So how can I make my head point to this? How can I make my head point to this? So for me to make my head point to this, it means I need to make sure the link part here, this part of the new node, is pointing to where? Is pointing to this node here. Isn't it? It is pointing to this node here because this is now going to be the second node. Isn't it? If this becomes the first, then this is going to be the second node. So I need to make sure the link part here now is pointing to what? To this first node here. Do you get it? So what is the link part here? This is the link part here. So what is the address of this node in which I want to point to? The address of this node is already the address that head is holding. Isn't it? It is already the address that head is holding. So here, instead of saying, or what I'm going to do here is I need to target the link part, or sorry, the next part, because this is the next. So I need to target the next part of this. So what is the next part? Don't forget, this is my new node, right? And this is what the str part of it. So, and this is what the next part of the node, right? So what I need to do here is simply say new node. Now I'm targeting the next part. New node next. That is the next what? The next member of the node, isn't it? So I want to update it. So what should this next point to now? So the next, like I said, is going to point to this first node, and the address of this first node is stored inside head. So it means that I can say this next now is equals to what? Is equals to head, because whatever the address is holding, or whatever head is holding, it is the address of this element, and that is where my first node needs to point to now. Do you get it? So here I will just say is equals to what? Is equals to asterisk head. So now I have my what? My node, this particular node here, having the value 50. Right? This is 50 because head here is what? Is 50. Isn't it? So now I have 50 here. So the next thing I need to do now is, by doing this, we know that now this is pointing to this. Isn't it? This new node now is pointing to this node now. Right? So the next thing I need to do is to make my head here, this head, point to this. So, and this is what? My new node, right? So all I need to do is I can just say my head is equals to what? Is equals to new node. So this way I will have my head pointing to the new node now. So all I need to do here is I'll just say asterisk head, right, is equals to what? Is equals to new node. That's all. So the first thing I did here is what? I pointed the new node to what? To the first node, to the initial first node, right? And the address of the initial first node is what? Is stored inside head. So that's why I said my new node is equals to what? Is equals to head. So after that line of code, this new node here is now pointing to this. Do you get it? So this now becomes what? The second node, right? So now this is not the first node. So we know that we cannot access the list because this is not pointing to the head. Right? So all I need to do, or let me say the head is not pointing to this list, the first node. So what I need to do is I will now modify head to point to what? To the new node. So that's why I added this particular line of code here. Where is it? This particular line of code. So head is equals to what? Is equals to new node. I believe this is clear. So the next thing I'm going to do here is just simply, it says what? Return the address of the new element, or null if it fails. So we've already checked for that. If new node is equals to null, it is going to what? Return null. So here I will just say return what? I will just return my head. So because head is now pointing to what? To the new node. Don't forget, by just this line of code, head is now pointing to what? To the new node. So this is simply how we can solve this problem. Okay, so let's run Betty. So Betty to add, sorry. Alright, so Betty is fine. So let's create the test file. So copy. Alright, copy. So vi, is it 2? Yeah, 2 main.c. Alright, so paste. Alright, so the next thing is we need to compile. So compile. See. Paste with 0 print list. Sorry, which task is this? This is task 2. Okay, I think, okay, I'm compiling 2 of it. So 2 add node and 0 print list.c. So mine is not print list.c. So it's going to be, my file name was what? 0 print.c, right? So press enter. Okay, so now as you can see, I'm calling malloc and strdup. So I need to include the header files for this. So I need to go to my list.h. So here I need to say hash include. What is the header file for malloc? The header file for malloc is stdlib.h. right? And that of the strdup is what? String.h, right? So string.h. All right, so I think that's all. So let's compile again. All right, so it has been compiled. So let's run the compiled file. So as you can see, we got the output. Z, William, Tasnim, up to what? Alexandru, right? Just look at it here. Just look at it, right? We got it, including what? The length of each of the strings. So this is simply how you can do it. So we've added a node at the beginning of what? Of a list. Okay, so don't forget, the first thing you need to do is create the node. After creating the node, you need to update the link part of the node to point to the initial first node in the list, right? And that initial first node in the list is the address of it is stored in what? In head. So it means that you can just call the new node and then say the address is now equals to what? Whatever head is holding. So after that, then you now point head to the new node, just like the way we did. Okay, so don't forget to add, commit, and push to GitHub, and then you can run your checks. So now let's move on to the next task. All right, so this task here says we should write a function that adds a node at the end of a list. So in this case, the node is going to be added at the end of the list, right? Unlike this, right? Here, it's going to be added here, the end of the list. So we are going to follow similar process, or let me say, not the same actually, similar process. But if you understood what we did in the previous task, you'll be able to get this one as well. So what I'm going to do here is I need to open the file. I think this is task 3, right? All right, so I have my Betty documented. So what I need to do first is, just like the way we did in the initial task, we need to create a pointer, which is going to hold malloc, right? So I'm going to call it new node, right? So after creating this, then what next? We need to create an unsigned int, right? And also a variable which we are going to use to hold the length of the string, just like the way we did in the previous task, right? So I have this. So the next thing is I need malloc to allocate memory. So I'll just say malloc. I'll pass in size of, lists underscore t. So this is something we did in the previous task, so it is not something new. So I need to check if new node, right, is equals to null. That is if malloc fails. So I will just say return unknown, right? So that is malloc failed, right? So the next thing we need to do is this. We need to store the str, right? Just like the way we did in the previous task. The str should be stored in the str member of new node, right? So I'll just say new node is equals to, new node str. I'm targeting the str member. Is equals to strdup string duplicate, and then I'll pass in the string I want to duplicate and store inside, right? Using the strdup function. So the next thing is I will find the length of the str string. So I is equals to 0, right? 0 str I not equals to the terminating null byte, then I plus plus, right? So here I will just say count plus plus. So I now have the variable count holding the length. So the next thing I'm going to do also is I will say new node. Now I'm targeting the length, right? So new node length is equals to what? My count. This is almost the same thing we did in the previous task, please. So that's why I'm not taking my time explaining this. So now I have the count stored in length. So the next thing I need to do is I need to update the next part of the new node. So assuming I created the new node now, right? We know that this is the word str part, right? And this is the word the next part. So I need to update this next part here, right? This next part is going to hold what? Null. Why is it going to hold null? Because for each node, whenever a node appears at the end, then the link part of that node is going to be null because it is not pointing to any other node. And from the question, it says add a new node at the end. So it means it is the last node we are going to create. And that node is not supposed to point to any node because it is the last node. So all I need to do now is update the next member of it. And I will also say new node next is equals to what? I will now say it's equals to null. So now I've assigned null to the what? To the link part of the new node we created. So making it what? The last node, right? So now it has started to take properties like the last node, right? Because the next part of it is what? Is null. It's not pointing to anything, right? So what I'm going to do here next is I'm going to create a temporary variable right? Or another pointer which is going to hold the head, right? Whatever this head is holding, I'm going to create a temporary variable to hold that. So here, let me add, let's call it TMP for temporary. So here I will just say temporary, that is TMP, now is equals to what? Asterisk head. So whatever head is, a copy of it is now stored in TMP. Do you get it? So the next thing we need to do is we need to check, what if the head is initially null? That is, if TMP is null. If TMP is equals to null, then it means that what? The head is not pointing to any node. That means there is no node existing already. Right? There is no node that is existing in the loop. There is no node. It is an empty list. Right? Because we've said that if the head is null, that is, it is the pointer to the first node. If it is null, it means there is no node. So I need to check if TMP, right? If TMP is equals to null, so it means there is no node. Right? And if there is no node, what should we need to do? We need to make this new node we created the only node. Initially, there is no node. So now, since we have created this node, then we should now make it the only node. We should now make it a node in the list. Right? So how do we do that? I will simply just say asterisk head is now equals to what? The new node we created. That's all. So it means the head now is going to point to what? To our new node, meaning that we now have just a single node in our list. So that is if the head is equals to null, that is TMP is equals to null. Okay, so else, right? Else, that is if there is a node in the list before we create our own. So if there is a node in the list, what do we need to do? That is if we have, assuming something like this. This is a node and this is also another node. Right? Let's say this is 10 and let's say this, okay, I'm supposed to use strings. So A, B, right? And let's say B and C, right? So let's say this is 10, so this is holding 10. So we know this is null, right? Since it is the last member of the list, it is the last node, right? Don't consider this one yet, okay? Don't consider this one yet. This is the last node. Right, that is before we link our own with what? With the existing node. It is the last node, right? This is the head. It's pointing to this, assuming this is holding the address 5. Right, assuming it is holding the address 5. So this is 5. Sorry, my screen is misbehaving. Don't know why. So this is pointing to this. Right? So what do we need to do now? How can we be able to target how can we be able to know the last node? So the last node, don't forget, it always have the null at the length, or sorry, at the next part of it. Just look at this. Like I said, the link part of every node is having what? A null. The link part of every last node, sorry, is having what? A null. So it means I can use this as a condition to loop over the entire node in the list. Right? So all I'm going to do here is I will just say while, isn't it, TMP. Right? I'm targeting the next member now. This means that as far as the next member, which is the link part, is not equals to null. So it means we have not reached the end of the string. As far as it is not equals to null, it means that is not the end. Sorry, we've not reached what? The last node. If it is not equals to null, then we've not reached the last node. The moment the next member becomes null, that is this part here, the moment this part is encountered, we know that we have reached the last node. Isn't it? So while this, right, while it is not equals to null, so I need to update my TMP. I need to say TMP is equals to what? TMP next. So this will move to the next member in the node. Okay, so after checking for this and it is not null, then it will update TMP to move to this node. That's just what I just did here. Okay, so this is how it will keep going until it encounters null. The moment it encounters null, it knows that, okay, now I've reached the last node. So since I have reached the last node, I need to update the link part of this last node to point to the new node I created, because it is this new node that I want to be the last node now. Right? So here I will simply add what? I will just say TMP here. The next of my TMP should now be equals to what? Should now be equals to new node. I believe you understood what I just did. Right? So TMP now, right? TMP now is going to point to the last node. isn't it, which has what? A null. So since it has a null, I need to update the next part of it. That is this part, right? The part that contains the link. So I need to update it to point to what? To my new node. So that's why I set this particular condition here. Sorry, this particular line of code. So tmp next is now equals to new node. So I've now changed my what? My node here to point to my new node. Isn't it? So that's simply what we need to do about this. Okay, so that's all. We've created the node. We loop over the list to look for the last node which has a null as its next member. When we find it, then we what? We updated the next member of that last node to point to the new node we created. That's all. So here I simply need to say return head. So I will now return my head. Right? Let me just make sure, ensure the return value. Okay, return to address of the new element. Yes. So already head is pointing to the new node. Right? So I'll just return this. So this is simply what we need to do. Okay, so let me let's run Betty. I think that's all. Okay, trailing white space on line 24. Sorry. All right, so let's see. Okay, yeah. All right, so let's run Betty again. All right, Betty is fine. So let's now create the test file. I think this test file is even the same with the previous one. All right, so let's copy. So vi, this is 3 main.c, right? So 3 main.c. So paste. All right, so I think that's all. We can now compile. So let's compile the program. Control C and then paste. So here my file name initially was print, right? So just take note, okay? I'm using a different file name, so ensure that your file name is the same as that of the intranet. All right, so as you can see, it has been compiled. So let's run the compiled file. So as you can see, we are also getting the same output here, right? 6 Walton whatsoever. Okay, so don't forget to add, commit, and push to your GitHub, and then you can run your checks. So we're going to stop here. In the next video, I'm going to continue from task 4 of this project. So the next video will be available on our website. So kindly visit the link in the description below to have access to the full course on this C programming. Thank you very much. We'll meet in our next session.